Hi to all. In this video, we are going to see the algorithm of how to make the Gauss-Seidel method. That is a step-by-step procedure for the Gauss-Seidel method. Okay, step one: assume all the bus voltage B 1 plus J 0 except slack bus. The voltage of the slack bus is a constant voltage and it is not modified at any iteration. So it will not be taken as a 1 plus j 0. Step 2. Assume a suitable value for specified change in bus voltage, which is used to compare the actual change in bus voltage between kth and k plus 1 iterations. Okay, step 3. The set iteration count k is equal to 0 and the corresponding voltages are V10, V20, V30 and so on Vn0 except slack bus. Okay, step 4: set bus count P is equal to 1 and step 5: check for slack bus. It is a slack bus, then goes to step 12, otherwise go to next step. Step 6: check for generator bus. If it is generator bus, go to next step, otherwise go to step 9. Okay, step 7: set VPK is equal to VP. Specify and phase of VPK as the kth iteration value. If the bus P is a generator bus where VP specified is the specified magnitude of voltage for bus P. Calculate reactive power rating. QP power K plus 1 cal is equal to -1 I mag multiply with Vp power K A and epsilon Q is equal to 1 to P minus 1 Y PQ VQ K power K plus 1 plus epsilon Q is equal to P to N Y PQ VQ K. That's a step 7. Okay, step 8. If calculated reactive power is within the specified limit, then consider the bus as generator bus and then set QP is equal to QP power K plus 1. Calculate for this iteration, go to step 10. Okay, step 9. If the calculated reactive power violates the specified limit for reactive power, then treat this bus as a load bus. Okay, so if QP K plus 1 calculated is less than uh, QP minimum, then QP is equal to QP minimum. QP K plus 1 calculated is greater than QP max, then QP is equal to QP max. Step 10. For generator bus, the magnitude of voltage does not change, and so for all iterations the magnitude of bus voltage is a specified value. The phase of the bus voltage can be calculated using Vp power k plus 1 at temperature. Temporary is equal to 1 by y pp multiply with pp minus j qp divided by vp power k minus epsilon ypq vq power k plus 1 minus epsilon vpq vq power k. Step 1. For load bus, the k plus 1 is the iteration value of the load bus. P voltage Vpk plus 1 can be calculated using Vp power k plus 1 temporary is equal to 1 by Ypp multiply with Pp minus j Qp by Vp power k minus epsilon y PQ VQ K plus minus epsilon YPQ VQ K. Step 2. No acceleration factor alpha can be used for faster convergence. If acceleration factor is specified, then modify the k plus 1, the iteration value of the bus P using Vp AC accelerated power k plus 1 is equal to Vp power k plus alpha multiply with Vp power k plus 1 minus Vp power k. Then set Vp power k plus 1 is equal to Vp ACC k plus 1 power. Okay. Step 13. Calculate the change in bus P voltage using the relation del Vp power k plus 1 is equal to Vp power k plus 1 minus Vp power k. Repeat step 5 to 12 until all the bus voltage have to be calculated. For this increments the bus count by 1. Go to step 5 until the bus count is n. Okay. Step 15. Find the largest of the absolute value of the changes in the voltage. So for that del V1 power k plus 1 comma del V2 k plus 2 and del V3 k plus 1 so on del Vn k plus 1. Okay. Let this largest value of the del Vmax. Check this largest change. Del Vmax is less than the specified tolerance. If del Vmax is less, go to next step. Otherwise, increment the iteration count and go to step 4. Okay. Um, so step 6, that's last step. Calculate the line flows and slack bus power by using the power voltage. Okay. This is a flow chart of Gauss-Seidel method flow chart. Okay, start. Read number of buses n. Read line admittance y. Read slack bus voltage for load bus pp qp for generator bus pp vp and qp max and q max qp max minimum. Okay, then first it will read, then for y bus matrix and determine ypq for p is equal to 1 to so on n and q is equal to 1 to and n. Okay, set vp is equal to 1 plus j 0 except slack bus. That's we told already, same one. Okay, then set iteration count k is equal to 0. Okay, then set bus count p is equal to 1. Okay, d here check for slack bus. If it is there, it has to go to a. If it is no, then check bus for generator bus. Okay, so temp set vp plus power k specific is equal to vp space. Calculate reactive power q p cal. If it is yes, it has to go to set qp is equal to qp minimum. If it is no, then it should go to y here. Check if k plus cal is the maximum. Okay, and this one b, this one come to here. Okay, okay, and evaluate the values. Okay, so check if del V max is less than epsilon. If it is yes, it evaluate the line flow and slack bus power. Then stop. If it is no, set k is equal to k plus 1. This will be the routine for the process. Advantage and disadvantage of Gauss-Seidel methods. Advantage, okay, calculations are simple and so the program task is lesser. The memory requirement is less for the Gauss-Seidel method, useful for small systems. Okay, disadvantage of Gauss-Seidel method is requires large number of iterations to reach converge, not suitable for large systems. Convergence time increases with size of the system. Because of that, this one will be useful for a small systems only. It can be used for big system. Thank you.